All right, here we are. It's part 2 of differentiation rules. This is from section 3.3 in the book, and well, here's where we finally leave the limit definition and finish out all these rules that we can just use whenever. And so let's do a little recollection here. If C is a constant, then the derivative with respect to x of C is 0, right? So we called this the constant rule. 2, if u sub x is a differentiable function and C is the constant above, then the derivative with respect to x of C u of x is C times the derivative of u of x, which is C times du dx. And then 3, if f of x equals x to the n, then f prime of x equals n equals n x to the n minus 1, which is the power rule. Okay. And we're going to develop a few more here that we can use whenever. So here we go. Oh, and also, let's put another one in here. If f and g are differentiable, then if you take the sum, it's just the sum of the derivatives. All right, so that's the sum rule. And you could put plus or minus in there. So here we go. Now we're going to look at products. Okay, so if f and g are differentiable, then we want to look at the derivative of f times g of x. Okay, and this is going to take some time here. So doing the proof, we take the limit as h goes to 0 of the product, so f of x plus h times g of x plus h minus f of x times g of x all over h. Okay, and now we use a famous calc trick here. So we're going to take f of x plus h, g of x plus h, and then I'm going to put this in a different color here. Let's use green. I'm going to subtract f of x plus h times g of x and add it. So all I've done is basically added 0 because I subtracted and added the same thing. And then off the end here we have f of x, g of x all over h. So this is calc trick 175, right? You add and subtract something and it implies you know what you're headed for, which I do. So now we're going to separate these out. And from the first two terms we factor out well, here, let's do this. No, this is fine. From the first two terms we factor this out. F of x plus h, and I don't like what I have in my notes here, so I'm going to fix it. Hold on. Here we go. This is better. F of x plus h times, well, so here we go, f of x, g of x plus h minus f of x plus h times g of x plus f of x plus h g of x minus f of x g of x all over h. So I moved the parentheses around. And now we have the limit as h approaches 0. So from this first term here, I'm going to factor an f of x plus h out. So we have f of x plus h. And let's go back to black here. What's left is g of x plus h minus g of x over h. Plus the limit as h approaches 0. From the second one, I factor out a g of x, and I have f of x plus h minus f of x all over h. Okay, and to be consistent, this should be in red because I factored a g of x out of here and here. All right. Okay, so continuing on, we're almost there. If you take this limit, you get g prime of x. And if you take this limit, you get f of x. So this is f of x times g prime of x plus this g of x stays fixed. And if you take this limit, you get f prime of x. So there it is. The product rule. The derivative of f of x times g of x is fg prime plus f prime g. And this is very, very handy for us. Okay. So let's look at an example here. What's the derivative of x squared times e of x? Right? So in this game, just so I'm crystal clear, this guy is f and this guy is g. Cool. So we have fg prime, which is x squared e to the x, plus f prime g. Easy peasy. Okay. And the second rule, well, what are we up to? 5. Number 6. Number 6 is called the Quotient Rule. And the proof goes exactly like this, so I'm not going to do it. I did this one so that I wouldn't have to do it twice. But this says if you look at the derivative with respect to x of a quotient, f of x over g of x, then you get g prime f minus f prime g all over g squared. And I did that wrong. Damn it. It's hard to do it when it's in f and g form. You'll see why in a second. So it goes this guy, G F prime minus F G prime over G squared. Now, that's not how I remember it. I go like this. I call the F function the high function and the G function the low function. And the derivative is low d high minus high d low all over low squared. That's how I learned it back in the golden ages. And that's how I still remember it. Low d high minus high d low. If you go on YouTube, you'll find some geeky songs and videos that have this low d high, high d low. It's like a country western thing. And so, for an example, let's look at, well, yesterday's quiz. Right? It was the last time you had to do the limit definition. So now with the quotient rule, f prime of x is going to be low d high minus high d low all over low squared, which is x plus 1 minus x over x plus 1 squared, and that's 1 over x plus 1 squared. Alright, so that finishes chapter section 3.3. And no more limit definition. I'll use it for proofs, but you don't have to use it for homework. And also note that I had tomorrow being 3-4 as our section, but it's actually going to be, tomorrow's going to be, so Thursday, section 3.5. So we're beginning trig tomorrow, and that's perfect because tomorrow night's co-rec is all on trig. And you shouldn't miss it if you are not comfortable with trig, because I'll be working with it for the next 3 weeks and for the rest of the semester. Okay.